In this video, we will solve certain problems involving Levi Civita symbol. We come to the problem, namely, show that Levi Civita symbol can be expressed as so this is a relation connecting Levi Civita to the Kronecker deltas, and we have to obtain it. The second problem is check the relation for Levi Civita 1, 2, 3, Levi Civita 2, 3, 1. Let us go to the solution part. Use the property of Levi Civita symbol epsilon ijk multiplied by epsilon pqr. This can be written as so it is IP, then we have IQ, then IR, and so on. JP, JQ, JR, and finally KP, KQ, KR. For PQR, taking values 1, 2, 3, we have so it is IP, so it is I1 now. Then we have I2, Kronecker delta I3, then and finally with K. Again, the value of epsilon 1, 2, 3 is plus 1. So it follows that Levi Civita ijk can be written as I1, I2, I3. We are just copying it and writing it afresh. J1, J2, J3, and K1, K2, K3. Using this expression for Levi Civita symbol, let us find the value of epsilon 1, 2, 3 and epsilon 2, 3, 1. We will rewrite this determinant putting 1 for I, 2 for J, and 3 for K to get and finally we have 3, 3. Now this is equal to, along the diagonal we have 1, 1, 1, and all other terms will be 0 because the indices do not match, and Kronecker delta is 0 if the indices are not identical. So this is what we have, and the value of it is 1. Next, epsilon 2, 3, 1. As before, we will now rewrite the determinant putting 2 for I, 3 for j and 1 for k to get delta 22 is 1, delta 33 is 1 and delta 11 is 1. And if we expand it, we get 1 into 1 into 1, so it is also 1. So that this formula is correct is verified also because we get correct results of Levi Civita symbol based upon this formula. Next problem, derive from this relation. Let us start the solution. We start with this expression and put for it the determinants as given in the problem. So it is delta I1, delta I2, delta I3 and then J1, delta J2, delta J3 and finally delta K1, K2 and K3, and similarly here also, and then we have to write it with L and then with M. Now the two determinants will be multiplied and this is as follows. First row into first row gives us and then first row into second row gives us now first row will be multiplied with the third row and we get now second row into first row second row into second row and then second row into third row, that gives now it is third row into first row. Third row into second row gives us and then the product of the third rows, this gives us We note that in the first element we have delta I in all the three terms. The second index is 1 in the first term, 2 in the second, and 3 in the third term, which means we have summed over the second index 1, 2 and 3. Therefore we can write delta IP where P runs over 1, 2 and 3. We are not using summation sign because we have employed Einstein's summation convention. The second element involves delta I, delta L in all the terms, and therefore let us write it as delta I, delta L, and the second index involves 1, 2 and 3, which means we have to sum over second index, so let us write it with P. P runs over 1, 2, 3. If P equal to 1, we end up with the first term, P equal to 2 the second, and P equal to 3 gives us the third term. The third element is written using delta I, delta M, and the second index is again 1, 2, 3, so we are summing over the second index. So we have got the first row. Now the second row starts with delta J, delta I, and we have to sum over the second index JL, JM, and the third row begins with delta K, delta I, delta K, delta L, and finally delta K, delta M. Contract P and we get delta II. Here also contracting P we get delta IL, and then delta IM, JI, then delta JL, delta JM. Now delta KI, delta KL and delta Km. So this determinant stands for the product of these two Levi Civita symbols, and this was indicated in the video on property of Levi Civita symbol, and we have derived it or proved it starting from the simplified expression of Levi Civita symbol. Next problem. Prove that epsilon ijk into epsilon ljk, this is equal to twice of Kronecker delta IL. And let us do the sum. Let us quote the relation that we did in the video on properties of Levi Civita symbol. Here the indices k, and here also there is k, and therefore we can write Kronecker delta IL into Kronecker delta JM minus Kronecker delta IM and then JL. In the given problem, two indices are equal, so JK, JK. So not only K but J should be equal to M. Therefore, let us rewrite this relation putting J for M to get again in the video on Kronecker delta we proved that Kronecker delta JJ is 3, and therefore we get 3 Kronecker delta IL minus, here we can contract J because J occurs in both the Kronecker deltas, and therefore we have Kronecker delta IL, and this is nothing but twice of Kronecker delta IL as we see in the right hand side of the given equation which we have proved. Let us do the next problem. we have to find the value of epsilon ijk Kronecker delta ij. So the solution is epsilon ijk, and here we note that the index j repeats, which means it is a sum over j, but presence of Kronecker delta means that only j equal to I term will survive. So we rewrite it with j is equal to I to get epsilon ik, and delta ii is 1. So this is what we get. Again, Levi Civita symbol involving two identical indices is 0. So this is 0. Let us go over to the next problem. We have to find the value of epsilon ijk into epsilon ijk. This is an important problem, and we will do it in 3 ways. The first method is let us consider which terms are non-zero, that is the surviving terms. So non-zero terms are those corresponding to ijk values to be 1, 2, 3, 2, 3, 1 and 3, 1, 2 for cyclic occurrence, the values of which are all +1, and 1, 3, 2, 2, 1, 3 and finally 3, 2, 1 for non-cyclic occurrence, for which the value of Levi Civita symbol is -1. So let us write down the 6 terms 1, 2, 3, 4, 5, 6, and we get and then 3 more terms. And we put the values, so it is 1 into 1 plus 1 into 1 plus 1 into 1, and then -1 into -1 and therefore we get 6. So 6 is the answer, and let us do it in a bit different way. Alternate epsilon ijk into epsilon ijk, and this can be dissolved into difference between two sets of Kronecker deltas, and we note that here we have I, here also we have I, so we can write j then kk and associate the indices j k with this Kronecker delta, and with this one we will have kj. And again, in the video on Kronecker delta we proved that this is 3, this is also 3. So what we get is 3 into 3 minus, we can contract the index k to get delta jj, which is 3 again, and therefore we have 3 into 3 is 9 minus 3, which is 6. Let us redo this problem in a different way using determinant, that is using the formula for the product of two Levi Civita symbols, namely this can be expressed in terms of a determinant. Here it will be II, then we will have ij, and the third element in the first row will be ik. Similarly, delta ji, delta jj, delta jk, and then we will have delta ki, then kj, and finally kk. and delta ii is 3, then delta jj is 3, and delta kk is 3 again. Let us open up the determinant to get 3 into 3 is 9, and then it will be cross product of these two terms, delta jk, delta ki minus 3 delta ji. Cross of delta ji delta kj minus thrice of delta ki, and this gives us contraction of k gives us delta jj, contraction of k gives us delta ji, 3 delta ij delta ji plus delta ik. Here we can contract j to end up with delta ik, and finally 3 delta ik into delta ki. So we end up with 27 minus 3 into 3, because this is 3. Contraction of j gives us delta ii, contraction of j gives us, contraction of say I gives us, contraction of k again gives us delta ii. Now this is 3, this is 3, this is 3, this is also 3, so we get 3 3s are 9, 3 3s are 9, and this turns out to be 999 with a minus sign, cancels this 27, and we are left with 3 plus 3 equal to 6. So the same answer is obtained, and also this formula is verified. Next problem, find where a and b are constants, vector r represents position vector, vector p represents momentum vector. This denotes Poisson bracket, and it is given that this is Kronecker delta ij. So we come to the answer. This can be written as a dot r can be written as ai ri, and b dot p can be written as say bj pj. Now as ai and bj are constants, so they can be taken outside the Poisson bracket, and we are left with now the value of this Poisson bracket is given to be Kronecker delta ij, so we are left with only surviving terms are those corresponding to j equal to I, and this is nothing but vector a dot b. So this is the answer. Next problem, we have to find the value of epsilon ijk where This is Poisson bracket, and it is also given that the Poisson bracket of PJLK is epsilon JKL PL, and Poisson bracket of Kronecker delta IL. Now the solution, let us copy the given expression let us use the given formula. Instead of this one, we can write epsilon JKL PL. So in the next step we have we can take epsilon JKL outside this Poisson bracket. So this is what we have, and the value of it is given to be Kronecker delta IL. So with this, the expression becomes into Kronecker delta IL. L equal to I, we have epsilon IJK into epsilon JKI, because all other terms corresponding to L not equal to I are 0 because of this Kronecker delta IL. Now this quantity can be written as minus epsilon JIK through an exchange of these indices, and a further exchange of indices IJ will bring another minus sign, so it will become, therefore minus minus is plus, we have IJK. And this means what we have for this given expression is the product of two Levi Civita symbols. One is epsilon IJK, the other one is also epsilon IJK, because we have brought this index sitting in the right extreme to the left extreme, and the value of this one was done in the previous problem to be 6.